10,000 years from now, what will the Earth look like? Humans at that time, how will it transform our planet? In 1815, a black curtain of dust, slowly enveloping the entire Earth. The culprit is a remote volcano in East Asia, Mount Tambora. This is modern history, the largest volcanic eruption ever. A total of 80 cubic kilometers of debris were ejected, took more than 100,000 lives. This is just Earth, the tip of the iceberg of unleashing energy. In ancient times, the eruption of Mount Toba in Indonesia. It is 50 times more powerful than Mount Tambora and ejected almost 30 times more material. If it were now, a volcanic eruption of this magnitude would be catastrophic, could kill hundreds of millions of people. Today, there are approximately 20 active supervolcanoes on Earth, although these beasts are sleeping. But the threat they pose, bigger than an asteroid impact. Instead of waiting for them to explode and cause disaster, is it possible to channel this energy? What about for human use? A NASA engineer proposed such a plan. The idea is to drill a series of holes into the ground. These holes are tens of kilometers deep, around the perimeter of the magma chamber. Then cold water is injected into the rock below. The water will be heated to a superheated state by the magma. It bounces this water back to the surface to remove the heat and gradually cool the magma. However, if the borehole is too close to the magma chamber, could lead to an accidental eruption. So the location of the drilling hole in the plan is very important. But if done properly, superheated water drawn from the ground will become a sustainable, renewable energy source. Over tens of thousands of years, by continuously extracting the energy from it, it could eventually cool the chamber completely. But if we want to fully protect our civilization, that's not just eliminate the threat of all existing supervolcanoes. We have to deal with it. All possible future supervolcanoes. Magma plumes from the mantle will continue to flock to the surface. These magma columns will continue to trigger new supervolcanic eruptions. The average frequency is once every 50,000 years. And learn to harness those forces. It means between a catastrophic collapse and the long-term survival of humanity, there is a path. But we need to manage, not just supervolcanoes. From the lithosphere to the atmosphere, every layer of the Earth are prone to drastic changes, threatening civilization and even all life. Our mission is to harness the power of technology to protect and manage these circles, building a safer and more livable planet, so that life and humanity can continue to thrive together a little longer. But to shape a habitable planet, we can start by creating a more ideal climate. In 1991, Mount Pinatubo erupted. This eruption put more than 20 million tons of sulfur dioxide, jet, into the stratosphere. This reflects sunlight. Globally, that's caused global temperatures to drop by about 0.5 degrees centigrade, and it lasted for nearly 2 years. A drop in temperature led the sea level in the next 10 years. The rate of increase has slowed down significantly. As global temperatures rise and climate disasters occur, this event inspired a bold idea. That is a simulated volcanic eruption that is artificially propelled. It's like applying sunscreen to the Earth, spraying sulfur dioxide high in the stratosphere, reflected sunlight, and that cooled the planet. In the stratosphere, it only takes a few tens of grams of sulfur dioxide, offset a few tons of carbon dioxide, 1 year's greenhouse effect. Spread them into the sky, can produce immediate results. To achieve a global economy, decarbonization buys time. But there's a problem. The specific effect of this could be unpredictable and uneven. Weather pattern, it can be volatile. And the conflict for control of the climate, it could even escalate into a loud war. Scientists from MIT, another concept was introduced: building a giant sunlight barrier in space. Its width is thousands of kilometers. Put it in the position where the attractive forces of the sun and the Earth balance each other, can reduce sunlight exposure by 1.8%, enough to bring temperatures down to pre-industrial levels. This barrier is made of silicon bubbles. It inflates and unfolds in space for easy transportation. If you need to pause, just give it up. To block enough sunlight, this solar barrier has to be huge. That's about the size of Brazil. In addition, there are other teams that have come up with space mirror systems to precisely direct sunlight. If temperatures drop too low in the future, you can use it to increase the heat from the sun. Large-scale ecosystem engineering to ensure the stability of the Earth system, a lot of help. In 2007, the United Nations launched the Great Green Wall Initiative. It's a huge project. Plans to plant an 8,000-kilometer forest belt across the entire African continent. This vast new forest, not only can it absorb 250 million tons of carbon, it also prevents desertification, enhancing food security, and create millions of jobs. To effectively manage our planet, it also requires a deep connection with the biosphere. And that includes protecting our natural carbon sinks. Take the Amazon rainforest. They are essential to human activities, ecological balance, power. In some cases, we can do biological things about life itself. Engineering retrofits create new forms. By adjusting the mechanism of photosynthesis, scientists have recently developed plants that grow 40% larger than natural plants. This foreshadows crops and plants could be extremely productive in the future. Scientists are also engineering algae so that it can convert sunlight into cleanliness, burning hydrogen fuel, those reprogrammed microbes of the future. It also generates electricity from sludge and wastewater. It is worth noting that, and we're still trying to create hybrids, woolly mammoth. Scientists tweak the genes of Asian elephants to conduct experiments. These creatures could be reintroduced to the Arctic. Right there, they will help keep the permafrost frozen, could prevent billions of tons of carbon dioxide leaked into the air. The future of genetic engineering likely to become the most powerful tool we have for managing the planet. It maintains ecological balance, make the biosphere more diverse and resilient. The miracle of the future, most likely not made of concrete or circuitry. They come from tiny cells. These are robotic trees. They mimic real trees, absorbs carbon into special plates that act as leaves. The captured carbon can be sequestered or recycled, and the cycle repeats itself. The amount of carbon that can be sequestered in such a machine, equivalent to 1,000 fire trees. In the future, large tracts of mechanical forests can be deployed in harsh environments. If there were 100 million such mechanical trees, we can offset all carbon emissions. There's excess CO2 in the ocean. Increase the acidity of seawater. It weakens the food chain. If those barren seabed were smashed to pieces, allows rock particles to absorb those excess carbon dioxide, restore the balance of the waters. All you need to do is place a nuclear bomb 5 kilometers below the seabed. Can crush enough rocks to sequester carbon emissions for 30 years. This nuclear bomb has to have a huge yield, more than 1,000 times more powerful than the Tsar's bomb. For such a nuclear explosion, the water pressure in the deep sea can suppress explosions and minimize radioactive fallout. And the best place to blast, possibly remote Calgaron seaweed. The seabed there is mostly barren and rich in basalt. It's the most extreme form of geoengineering. It is also the most dangerous way. But to protect the oceans and the lives of billions of people, even the most extreme ideas are worth considering. To find safer ways to manage the oceans, we don't have to go too far from the coast. Artificial reefs built from sunken ships and man-made materials can be turned into a bustling underwater city. Some studies have shown that fish abundance in this scenario, compared to the bare seabed, it can increase by almost 20 times. Widely distributed artificial reef can pass through for trillions of corals. Shellfish and seaweed provide habitat to enhance the natural carbon absorption capacity of the ocean. Because these organisms are growing, carbon is also captured to varying degrees. On a macro scale, these reefs also provide a strong natural defense. They can absorb wave energy to reduce erosion and storm surge. The fountains of our planet, it's not just the liquid ocean. There are also glaciers and ice sheets that need to be protected. They cool the world and curb sea level rise. This is Sweets Glacier in Antarctica. A huge ice sheet stretches for about 120 kilometers, rising ocean temperatures, causing warm ocean currents to meander deep into the base of the glacier, leaving glaciers bursting and out of balance. If it completely collapses, collapsing into the sea will cause sea levels to rise by 5 meters, flooding coastal cities around the world. To avert disaster, an engineer at the University of Lapland, a bold plan has been proposed. The idea is build a giant underwater enclosure 100 kilometers long, surrounding the glacier. The goal is to block warm ocean currents, touch the bottom of the ice. The massive underwater barrier will be designed to can withstand the impact of icebergs. And in the event of a problem, it can be demolished very quickly. At the opposite pole of the Earth, people are also proposing ambitious plans to stop the melting of Arctic sea ice. This is the Large Wind Pump Array project. These wind pumps can pump seawater out during the winter, sprayed on the Arctic surface. This seawater freezes rapidly in freezing air. In addition, There's actually a design for this polar umbrella. It can float in Arctic waters, using solar energy to extract seawater and create new ice. People can deploy them at the area where ice is melting the fastest. These umbrellas will cast cooling shadows, thereby lowering the surface temperature, bringing Arctic ice back to life. But all these grand plans share a common problem. Each of them, it requires tremendous resources and energy. Where are we going to get the power and the materials? And the whole idea of solving energy needs. How will they shape the future of our planet? In the past 2 centuries, our energy use is growing exponentially. That's a 7,000% increase. Behind the huge energy consumption, that's a 100-fold increase in global economic output. To maintain this level of growth, finally, it will require the generation of trillions of additional watt-hours per day energy. As people gain access to solar energy more efficiently, now it only takes 0.3% of the Earth's surface. Lay out solar energy. There are enough panels for an entire civilization. And the frontier of the solar future would be one of the most inhospitable places on Earth. Desert. Deserts provide ideal conditions for solar power generation. It's a vast, flat landscape, rich silicon resources, and continuous sunlight. There's a plan in the Sahara Desert, building large-scale solar power plants. The power generation capacity of a power plant, that's 4 times the current global energy use. The coverage area of solar panels in the scheme, that's about 20% of the desert. This is likely to cause severe side effects. Dark solar panels, capable of absorbing extra heat, but it disrupts global weather patterns and causes temperatures to soar, especially in the polar regions. No matter how or where we get our motivation, generating too much energy on Earth, eventually it will be fatal. If our consumption growing at just 2% a year, in just a few hundred years, will exhaust what the Earth has to offer, all available energy sources. But here's the problem. At this scale, waste heat generated by energy consumption that would warm the planet by more than 20 degrees centigrade. This would result in large areas of the Earth become uninhabitable. How do we balance continued energy growth, relationship with a safe and stable planet? If we put large-scale solar arrays placed in space, we can obtain almost 24 hours uninterrupted sunshine. Then, in the form of lasers or radio waves, transmit energy back to the ground. The rail power system will remove its waste heat spread into the cold of outer space, rather than heating the Earth's atmosphere. China is currently planning a 1-kilometer wide solar array. Its long-term goal is to transmit thousands of objects from orbit, MW of clean power. A team from Oxford University also planning a large space station for power generation. Although these facilities in orbit, it can harvest energy in space and transmit it back to the ground. But they can still have the problem of lung heat. Because of energy, finally, it was added to the Earth's system. The radical solution is transferring energy-intensive industries into space. Is that so? Energy can be found outside of Earth's fragile systems, collected, consumed, and radiated. To effectively send all materials into space, we need some really bold ideas. Like a highway to the sky, space elevators will provide safe and convenient access. Let's take our civilization to the next technological frontier, enabling the construction of next-generation space infrastructure become possible. To build it, a cable over 36,000 kilometers long is required, dropping from a counterweight in space, then anchored to a port station on the equator. It will lead to a space station positioned in a geostationary orbit, where attractive forces and centrifugal forces balance each other. A laser or nuclear-powered rail car ascends along the cable, transporting dozens of tons of goods at a time. This will reduce the launch cost down below $100 a kilo, 50 times cheaper than now. This will also accelerate solar power arrays, orbital data center, large-scale development of research stations and spaceports, laying the foundation for new orbital frontiers. But if you want to build this dojin that leads to 9 days, it's going to be huge. It would have to be much stronger than anything we have today. Suck it in. And if you want to transfer industry from Earth to space, it also comes with great risks, like space debris. A piece of metal less than the size of a fingernail, detritus. It can penetrate satellites and infrastructure in space and set off a chain reaction of destruction. This generates more debris. To solve this problem, people will deploy artificial intelligence lead laser system. It can quickly identify and deflect small fragments, and for those larger fragments, can capture them and take them out of orbit. If people can manage these risks, then the space elevator, maybe it's just this planet, the beginning of a grander vision for the future. This is the crowning of spatial infrastructure, iconic structure, orbital ring. This superstructure could become the backbone of our future civilization. It's an energy-gathering vehicle, the center for climate management and housing in one. The basic form of an orbital ring is a simple ring. It's about 200 kilometers above the ground, orbiting the Earth. It can be built as a free-floating structure, connecting many trickles and gutters on Earth. Some of the dots could even be suspended skyscrapers, hanging down from under the rail ring as a launching point research center and sky city. His inner side does independent rotation, generating artificial gravity through centrifugal force. Make the entire inner area habitable. Although there is currently no technology to carry exogenous rings, simulated gravity, but it can still be used as a microgravity industry and study habitat areas. People can also be at different inclinations, building complex ring networks. Is that so? Can provide fast access to any area on Earth, point-to-point travel. These layers can extend far out, maybe even connect to the moon. But the sheer size of the orbital ring itself, it's dangerous. For example, a shadow as wide as the ring itself sweeps the Earth once a day. For narrower ones, the sea has no impact on the ecosystem below, have too much impact. If the width exceeds 1,500 kilometers or a wider ring, it will cause serious disruption to the climate because he blocks the sun for an hour every day or longer. Such an orbital ring would be a towering feat of engineering. To build it requires tens of billions of tons of raw materials, and it requires continuous active control by a computer to prevent it from collapsing. In order not to affect the Earth, the resources required to build the orbital ring, it can be mined from asteroids. You can put asteroids, pull near the track ring, conduct mining. Although all this, it may seem like a distant dream, but there will always be a day in the future. Huge orbiting cities and arable land will orbit the Earth, become the new human frontier. The future will be created by us.